So today you will be solving algebraic equations using inverse operations. So you're going to be using the abstract method. When we're solving algebraic equations, we talked about our goal is to isolate the variable so that way we can find the value of that variable. When we're isolating variables, in order to do so, we need to use inverse operations. And inverse just means the opposite. So yesterday we also talked about, well, what is the inverse of addition? It's subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And then, sorry, you can't see it. The inverse of division is multiplication. I made this little picture right here, which is something you can just draw in your notes, and it just tells you the inverse of addition, subtraction. The inverse of subtraction, addition, inverse of multiplication, division, and inverse of division, multiplication. This is just something that I use. All right, so first we have p plus 6 equals 13. The p is not by itself. My goal is to get that variable on one side of the equal sign all alone. So in order to get rid of this plus 6, I'm going to have to subtract 6. And when I subtract 6, this gives me 0, so now it's gone. But remember, we have to keep that balancing scale. So if I subtract 6 from my left side, I'm going to have to subtract 6 from my right side. So on my left side, all I have is p. This is my equal sign, and 13 minus 6 gives me 7. P is equal to 7. Now I can check this by, instead of using P, I'll use 7. So let me clear this. So 7 plus 6 equals 13. Well, 7 plus 6 does equal 13. This equation is true, so I know I'm correct when I say P is equal to 13. Our next one is k minus 10 is equal to 7. Gonna just split this here. I want to get k all by itself, but I have this negative 10 sticking around. To get rid of this negative 10, this subtracting 10, I'm going to have to add 10. This gives me 10 zero pairs, so now they're gone. All I'm left with is k on this side. If I added 10 to my left side, I have to add 10 to my right side. 7 plus 10 gives me 17. K is equal to 17. Again, if I want to check this, instead of k, I substitute the 17. 17 minus 10 is equal to 7, so I know I am correct. Go ahead and solve 9, 10, 11, and 12. And once you're done, unpause the video and check your answers. For number 9, to get f by itself, you should have subtracted 5 from both sides, giving you f is equal to 9. Number 10, you should have subtracted 11 from both sides, giving you g is equal to 15. For 11, you should have added 6 to both sides, so w is equal to 16. And then for number 12, we should have added 9 to both sides, giving you z is equal to 30. Next, we have 2x equals 12. Well, I know to undo multiplication, I use the inverse operation of division. So I'm going to divide by 2. That cancels this out, leaving me with only an x. Well, if I divided my left side by 2, I have to divide my right side by 2. 12 divided by 2 gives me 6. X is equal to 6. Our next one, sorry, let me clear this, is y divided by 6 is equal to 5. So I'm just going to rewrite this. I have y divided by 6 is equal to 5. So I know the inverse of division is multiplication. So to get rid of this, I'm going to have to multiply by 6, which gets rid of this. And if I multiply my left side by 6, I'm going to have to multiply my right side by 6. So I'm left with y is equal to 30. Now, some of you might have a question on, well, how does this work? So if I have 6 times y over 6, it's just like multiplying fractions. Well, this 6 is over 1. What is 6 times y? That gives me 6y. 1 times 6 is 6. Well, what is 6y divided by 6? It gives me 1y, which is the same thing as just y. There is no reason for us to have to do this every time. If we understand this concept, then we know if I multiply y over 6 by 6, that's going to cancel this out and leave me with just that variable. Go ahead and complete 14, 15, 16, 17. When you're done, unpause the video and check your answers. Okay, for number 14, we have 6 times a is equal to 42. So we need to get this a all alone, but it's being multiplied by the 6. So in order to do that, you should have divided by 6. And if you divide one side by 6, you have to divide both. This cancels each other out. I'm left with just an a. And a is equal to 42 divided by 6, which gives me 7. For 15, the b is not by itself. It is being multiplied by that 13. To get rid of that 13, I'm going to have to divide by 13, and I'm left with just b. I have to divide this side by 13, and b is equal to 5. Then we can go ahead and take a look at number 16. I have m divided by 8 is equal to 9. Well, if I have division, the inverse of division is multiplication. So I can multiply by 8. When I solve this, I'm left with just m. And if I multiplied one side by 8, I have to multiply the other side by 8. So m is equal to 72. And lastly, we have 12 is equal to n over 7. I have division again, so in order to get rid of that division, I'm going to have to multiply by 7. That gets rid of that, and I'm only left with n. Well, if I multiply this side by 7, I'm going to have to multiply this side by 7. And so 12 times 7 is 84. So n is equal to 84. We're going to take a look at some examples with fractions and decimals. It doesn't change the procedure. The only thing you have to do is remember the rules when adding, subtracting, multiplying, and dividing fractions and decimals. So here we have r plus 1/2 is equal to 3/4. Well, I know to get rid of this positive 1/2, so that way r can be by itself, I'm going to have to subtract 1/2. And that cancels this out. Well, if I subtract 1/2 from this side, I'm going to have to subtract 1/2 from my right side. So r is equal to 3/4 minus 1/2. When I'm dealing with fractions, I always make sure that I write them next to each other so that way I can keep it organized. When subtracting fractions, I need to have common denominators. So I know that 4 is going to be a common denominator, so I'm going to change this to 4. And if I multiply 2 times 2, that gives me 4, so I'm going to multiply my 1 by 2. So I have a 2. So 3 minus 2 is 1, and my denominator stays the same. So r is equal to 1/4. Now let's go ahead and let's take a look at our next example. We have k minus 2.4 is equal to 6.8. Well, here I have subtraction. I have a negative 2.4. In order to get rid of this, I'm going to have to add 2.4. That cancels that out. If I added 2.4 to this side, I'm going to have to add 2.4 to this side. 4 and 8 gives me 12. 6 and 2 gives me 8 plus 1 is 9. Remember, when I'm adding or subtracting decimals, I line up the decimals and I bring it straight down. So K is equal to 9.2. Next, we have 2/5 times S is equal to 3/4. Okay. So I have multiplication happening here. In order to undo multiplication, I divide. So I'm going to be dividing by 2/5, which cancels this out, and I'm only left with S. So S is equal to 3/4. And if I divided this side by 2/5, I'm going to have to divide this side by 2/5. Then I have to remember, well, what is my rule when dividing fractions? I use keep, change, flip. So 3/4 stays. Change division to multiplication and flip my fraction to the reciprocal, which is 5/2. 3 times 5 is 15, and 4 times 2 is 8. Well, now I have an improper fraction, or a fraction greater than 1. I'm going to go ahead and make this a mixed number. 8 goes into 15 once. I have 7 left over out of 8. So S is equal to 1 and 7/8. If you don't think that's true, go ahead and plug in 1 and 7/8 for S and solve, and you will end up with 3/4. Our next example is G divided by 2.5, which is equal to 4.1. In order to solve for the variable G, if I have G divided by 2.5, in order to undo that division, I'm going to have to multiply. Go to multiply by 2.5. That cancels this out, and I'm just left with G. But if I multiplied my left side by 2.5, I'm going to have to multiply my right side by 2.5. So 5 times 1 is 5. 5 times 4 is 20. I put my 0 for my tens place. 10 times 1, or 2 times 1, is 2. And 2 times 4 is 8. When I add these together, I get 5, 2, and 10. My decimal has moved one place here and one place here. So in my answer, it's going to move a total of 2 times. So I start in the back. 1, 2. G is equal to 10.25. This is a 2, not a Z. Go ahead and complete number 19 and 20. When you are done, go ahead and check your answers. So for 19, we have K plus 1/8 equals 7/8. Well, in order to get rid of this 1/8 so that way K can be all by itself, I'm going to have to subtract 1/8. That's now gone. I have K all by itself. Subtract 1/8 from this side. That looks like a multiplication sign, Subtract. And I end up with, that's really bad. Let me try that again. 6/8. And it says to write my answer in simplest form, so I know I can divide both of these by 2. So I have 3/4. K is equal to 3/4. We look at number 20, we have 4 times P is equal to 3/4. Well, I have 4 times P. In order to get that P by itself, I'm going to have to use the inverse operation of multiplication, which is division. I'm left with just P. And if I divided this side by 4, I'm going to have to divide this side by 4. So divide by 4. Well, now I'm dividing fractions, and I know when I'm dividing fractions, I have to keep, change, flip. So 3/4 is going to stay. I'm going to write it over here. So I have 3/4. I'm going to change my division to multiplication. And I'm going to flip my second fraction to the reciprocal of 1/4. 3 times 1 is 3. 4 times 4 is 16. So P is equal to 3/16.